Hello everyone, my name is Sovanrithy Chea and I'm a sophomore majoring in civil engineering in Paragon University. Today I will be introducing you to a website called PermaLearn. In another name, this is a 2D structural analysis tool. So you can do structural analysis in 2D shape using this tool. And I will be going through some general and brief introduction through some parts of the tool, like the member, the support, and how to add loads, how to edit loads, and also find the display solution afterwards. So I'll be using an example from the textbook to show you guys. So the example I'm going to use today is this simple beam that consists of two support on each side. It is 9 meter long and it has a vertically distributed load of 6 kilonewton meter pushing downward. So first we have to add the member, which is the beam, which is 9 meter. You can head on to this part, which is member, and you can add, you can see here that the begin x coordinate and the begin y coordinate is 0, 0. If you do not want to begin your coordinate at 0, 0, 0.00, which is right here, you can change it accordingly. But I'll just start mine with at 0.00. So and also if your diagram is going upward, then you can add your descent vertically. But since my diagram is going horizontally, I'll add the horizontal descent, which is 9 meter. You can just click type in 9 and click enter. And you will see that it display a white line here that represent the 9 meter beam. Next up, we have to add the two support on each side, which is a pin and roller. So we head on to the support section, and on the joint coordinate, you can see two point, which is point A and point B. You can click on one to see. When you click on one point, you will see that this orange point pop up, which means that you selected that point. If this is not the point that you wanted, you can change it by going to other point. So at point A, it is a pin. So we'll add a pin support type. We go to support type and add pin and add it. And point B is roller. So we can add the roller support. For if you were to make a mistake in this part or even on the member, you can come to this section right here that allows you to edit. So let's say at point A, it is a fixed support instead of a pin. You can come at edit and change it to fixed and click edit. And another way you can do it is by just deleting it and re-adding it. So there's two ways you can do it if you were to make a mistake. So after we add support, we have to add this vertically distributed load. So we head on to this linearly distributed load. If your exercise or problem is a single or concentrated forces or load, you can check out this part, which is point load and joint load. But since our example doesn't have those load, only have the linear distributed load, I'll just show you the distributed load. So since we only have one member, this will only show you one. And we have to add the load type. It is vertically load because it's pushing downward. And it is 6 kilonewton per meter. So you can just write 6 kilonewton per meter. But you can see here that we made a mistake because our diagram show that the force is pushing upward. Our example here, it shows that the force is pushing downward. So we can change it by going to the edit part and change it to -6, which click edit, and you see that it's now correct and exactly like our example. And after we added all our support, load, forces, and member, we can head on to the solution and we can see. You can find the reaction force here. It will show the reaction force at point A is 9 kilonewton, and at point B, the reaction force is 18 kilonewton. You can also see the normal forces, which is 0 Newton, that represented by this pink line. You can also see the shear forces, the shear force diagram. Yeah, this represents the shear force diagram. And lastly, the bending moment. The bending moment, there's also the reverse of bending moment right here, which is just the reverse of this diagram. Another part I want to mention is, let's say you want to see more detail, more detail point of uh, this this diagram. You can just come to this mesh size, which tells you like if the lower the mesh size, the more point you can see on your diagram. The bigger the mesh size, the lesser point you can see on your diagram. So if you can change it to 0.5 here and save option, and you can see that it shows more points on our loads. So yeah. So that is it for my part. I hope you can check out this 2D structural analysis tool. Thank you for watching my videos.